June 6, 1944, 5:37 in the morning, Crisbeck Battery, Normandy coast. Oberleutnant Sir C. Walter Olmsen pressed his field glasses against the concrete observation slit, scanning the pre-dawn darkness of the English Channel through the salt-stained glass. What he witnessed in those first moments would haunt him for the rest of his life, not because of its horror, but because of its mathematical impossibility. Stretching from horizon to horizon, as far as his trained naval eye could see, lay the largest armada in human history. 7,000 Allied vessels, their dark silhouettes emerging from the morning mist like an unstoppable tide of steel and determination. Battleships, cruisers, destroyers, landing craft, merchant vessels, troop transports, hospital ships, supply vessels, each one representing a fragment of industrial might that Germany had never truly comprehended or imagined possible in their darkest strategic nightmares. In his concrete bunker, surrounded by the 4 massive 210mm guns of the Crisbeck battery, Olmsen realized with crystalline clarity that everything the Wehrmacht had been told about Allied capabilities was catastrophically wrong. This was not the scattered, desperate gamble of a weakened democracy. This was the methodical deployment of industrial supremacy on a scale that rendered German resistance mathematically futile and strategically hopeless. What Olmsen could not have known was that his battery, designed to be an impenetrable fortress of the Atlantic Wall, would become a front-row seat to witness the collapse of Nazi Germany's fundamental assumptions about modern warfare. The invasion fleet before him represented not just military might, but the complete transformation of American industrial capacity into the world's most devastating war machine. For months, German intelligence had intercepted reports of massive Allied preparations across the British Isles. Coastal reconnaissance flights had photographed endless rows of landing craft assembled in British ports stretching from Scotland to Cornwall. Radio intercepts had documented the movement of entire armies across England. Luftwaffe pilots returning from desperate missions over Britain had described airfields packed with aircraft in numbers that seemed impossible. Yet, German high command had dismissed these reports as elaborate deception operations designed to mask Allied weakness. The intelligence reports that had reached German commanders throughout 1943 and early 1944 had been dismissed as Allied propaganda designed to induce strategic paralysis and military confusion. Claims that American shipyards were launching Liberty ships in 4 days. Reports that Ford's Willow Run plant was producing a B-24 Liberator bomber every 63 minutes. Statistics showing Allied aircraft production exceeding German output by ratios of 5-to-1. Standing in his observation post, Olmsen was witnessing the physical manifestation of those supposedly impossible numbers. Each ship in the invasion fleet told a story of American industrial mobilization that German planners had declared impossible. The LST's carrying tanks had been mass-produced in shipyards that employed women welders working 3 shifts around the clock. The destroyers providing gunfire support had rolled down assembly lines where workers who had been building automobiles 18 months earlier now constructed warships with unprecedented speed and precision. The naval armada approaching the Norman coast represented industrial achievements that challenged fundamental German assumptions about warfare. In Hamburg's Blohm and Voss shipyard, German engineers had struggled for months to complete a single destroyer, yet American shipyards had launched entire fleets in the time it took Germany to build individual vessels. The Kaiser shipyards alone had produced more tonnage in 1943 than the entire German maritime industry had built since the beginning of the war. At exactly 600 hours, Olmsen's battery opened fire on the invasion fleet with thunderous precision and deadly accuracy. The massive guns, each capable of hurling a shell 18.5 miles, found their range quickly. Through his observation equipment, he watched as one of his shells struck USS Corey, the American destroyer, breaking apart and sinking in the shallow waters off Utah Beach. 24 American sailors died in that single hit. But even as his gunners cheered their success, Olmsen understood the futility of their achievement. They had sunk 1 destroyer from a fleet of 7,000 vessels. The mathematics were inescapable. At this rate, his battery could fire continuously for years without making a meaningful dent in the Allied armada. The German artillery crews serving the Crisbeck battery represented the finest traditions of Prussian military excellence. Each man had been trained for months in the precise calculations required for long-range naval gunnery. Their equipment, manufactured by Krupp with tolerances measured in fractions of millimeters, represented the pinnacle of German engineering. Yet, their technical superiority in individual weapon systems was overwhelmed by Allied superiority in quantity and coordination. The air battle unfolding above the invasion beaches confirmed Olmson's growing despair. Allied aircraft swarmed the Norman sky in numbers that defied comprehension. Fighters, fighter bombers, medium bombers, heavy bombers, transport planes, gliders, reconnaissance aircraft. For every German plane that appeared, 46 Allied aircraft filled the sky. The Luftwaffe, once the terror of European skies, had been reduced to token resistance against an aerial armada that blotted out the sun. Major Hans Priller and Sergeant Heinz Vodarchik, flying the only two operational Fu-190 aircraft in Normandy, made desperate attacks against the invasion fleet. Their twin radial engines screaming at maximum power, they dove through walls of Allied fighter aircraft to strafe the beaches. Both pilots were veterans with dozens of combat missions, their aircraft equipped with 20mm cannons capable of devastating any individual Allied plane. Yet their heroic efforts were statistically insignificant against an air armada that included over 13,000 Allied aircraft. Throughout the morning, Olmson watched as wave after wave of landing craft approached the beaches with methodical determination and relentless precision. The Higgins boats, DUKW amphibious vehicles, and specialized landing craft represented a logistics miracle that German military doctrine had declared impossible. Each craft had been designed for a specific purpose, manufactured in quantities that exceeded Germany's total production of all military vehicles, and deployed with a precision that spoke to organizational capabilities beyond German comprehension. The landing at Omaha Beach, visible from his position, initially seemed to validate German defensive planning. American troops were pinned down on the beach, suffering massive casualties from machine gun positions and artillery fires. For several hours, the invasion appeared to be failing at the most heavily defended sector. Olmson's telephone reports to regimental headquarters spoke of American bodies littering the sand, of landing craft burning in the surf, of an assault that was grinding to a bloody halt. The German defenders at Omaha Beach, primarily elements of the 352nd Infantry Division, had prepared their positions with meticulous care. Machine gun nests were positioned to create interlocking fields of fire. Artillery observation posts provided precise targeting data for mortars and field guns. Concrete bunkers had been constructed to withstand direct hits from naval gunfire. Every approach to the beach had been pre-registered for artillery fire. The defensive system represented everything that German military engineering had learned from 4 years of warfare. But then, the American destroyers moved in with devastating effect. USS Satterlee, USS Thompson, USS McCook, and other destroyers approached the beach so closely that their hulls scraped the sand. At ranges measured in hundreds of yards rather than miles, these warships opened fire on German positions with a precision and volume that no fixed fortification could withstand. Each destroyer carried more firepower than an entire German artillery regiment. Their 5-inch guns, firing continuously, systematically destroyed every German strongpoint that could be identified. What Olmson witnessed was not just superior firepower, but superior coordination. The American naval gunfire was directed by shore-fire control parties who had landed with the assault troops. Radio communications allowed instantaneous adjustment of fire. Target identification was relayed from aircraft circling overhead. The entire system functioned as an integrated weapons platform that could concentrate devastating firepower on any point of resistance within minutes of identification. The radio systems enabling this coordination represented another dimension of Allied technological superiority. Every American landing craft carried multiple radio sets operating on different frequencies. Tank crews could communicate directly with supporting aircraft. Artillery observers could call for naval gunfire while simultaneously coordinating with land-based artillery. The entire invasion force operated as a single communications network where information flowed instantly across all levels of command. By noon, the German defenses at Omaha Beach were collapsing, not because of American heroism, though that was present in abundance, but because of systematic application of overwhelming firepower. The 352nd Infantry Division, which had seemed capable of throwing the Americans back into the sea, was being systematically destroyed by naval gunfire that they could not return, air attacks that they could not counter, and artillery support that exceeded their ammunition supplies by orders of magnitude. The strategic situation became clear to Olmson as the day progressed. This invasion was not dependent on capturing existing ports. Intelligence reports filtering back from other sectors described something called mulberry harbors, artificial ports that the Allies were assembling off the Norman coast. These prefabricated harbors, constructed in British shipyards and towed across the Channel, would provide the deep water docking facility facilities necessary to sustain an invasion force of unprecedented size. The Mulberry Harbors represented engineering capabilities that German planners had never considered possible. Each artificial port required more steel and concrete than many German cities contained in their entirety. The floating breakwaters, constructed from massive concrete caissons, each weighed thousands of tons and had been towed across 100 miles, treacherous open ocean. The concept was revolutionary and terrifying. The Germans had based their coastal defense strategy on denying the Allies access to existing ports. By bringing their own ports with them, the Allies had rendered the entire Atlantic Wall strategically obsolete. The massive concrete fortifications, built with 13 million cubic meters of concrete and 1.5 million tons of steel, had been negated by an idea of simple genius. German coastal defense doctrine assumed that invading forces would require existing port facilities to sustain major operations. The Atlantic Wall had been designed to make capturing those ports impossible, but Allied engineers had solved the problem by eliminating the need to capture ports at all. Throughout June 6th and the following days, Omsen's battery continued to engage Allied targets with determined resistance. They achieved several more hits, damaging landing craft and causing casualties among the invading forces. But for every target they struck, hundreds more appeared. The Allied supply system operated with a redundancy that made individual losses irrelevant. Ships damaged by coastal artillery were towed away and replaced within hours by identical vessels carrying identical cargoes. The German 7th Army, responsible for defending the Norman coast, had been optimized for a different kind of warfare entirely. With approximately 50,000 troops scattered across hundreds of miles of coastline, they faced an invasion force of 156,000 troops concentrated on a 50-mile front. The numerical disparity was compounded by qualitative differences that became apparent as the battle continued. German communication systems, dependent on telephone lines that were severed by Allied bombing and artillery, broke down completely. Units lost contact with their headquarters. Reinforcements could not be coordinated. Artillery fires could not be adjusted. The Wehrmacht's emphasis on rigid command structures became a fatal weakness when those structures were severed by Allied firepower. American communications, based on radio systems in every vehicle and aircraft, continued to function despite battle damage. Tank crews could call for air support. Artillery observers could adjust fires in real time. Naval gunfire could be directed by forward observers with the assault troops. The entire invasion force functioned as an integrated system where information flowed freely and decisions could be implemented immediately. The industrial foundation of Allied superiority became increasingly apparent as the Norman battle continued. German tank units, when they finally reached the battlefield, discovered that they were outnumbered not just by Allied tanks, but by the entire Allied production system. A German Panzer IV, destroyed in combat, might be replaced in weeks or months if replacement parts and fuel could be found. An American Sherman tank destroyed in combat was replaced within days by another Sherman rolling off assembly lines in Detroit that were still operating at full capacity. German panzer divisions arriving at the Norman battlefield carried with them the accumulated experience of successful campaigns in Poland, France, and Russia. Their crews were veterans who had mastered complex tactical maneuvers under the most difficult conditions. Their equipment, while less numerous than Allied tanks, incorporated technical innovations that gave individual German vehicles significant advantages in direct combat. Tiger and Panther tanks mounted guns that could destroy any Allied tank at ranges exceeding 2 miles. Yet these qualitative advantages were systematically negated by Allied quantitative superiority. For every German tank that reached the battlefield, Allied forces deployed 5 Sherman tanks, 3 Stuart light tanks, multiple tank destroyers, and specialized armored vehicles designed for specific tactical situations. German tank crews found themselves fighting not against individual Allied tanks, but against entire armored ecosystems designed to overwhelm any opposition through concentrated firepower. Allied air superiority made German reinforcement and resupply nearly impossible. Luftwaffe fighters, when they appeared at all, were overwhelmed by Allied fighters that outnumbered them 46-1. German transport columns moving toward the battlefield were subjected to continuous attack by fighter bombers that operated with near impunity. Railway systems, bridges, fuel depots, ammunition dumps all came under systematic attack by Allied aircraft that seemed to be available in limitless quantities. The Wehrmacht's tactical excellence, honed through years of successful campaigns, proved insufficient against the weight of Allied material superiority. German troops fought with skill and determination, but they were fighting fighting an enemy that could afford to lose equipment and men at rates that would bankrupt any other military force. The mathematical reality of industrial warfare was overwhelming traditional concepts of military excellence. General Friedrich Dollmann, commanding the 7th Army, received reports throughout D-Day that painted an increasingly desperate picture. His coastal divisions were being systematically destroyed by firepower that exceeded anything in German experience. Reinforcements attempting to reach the battlefield were being interdicted by Allied aircraft, operating with complete air superiority. Communications with higher headquarters were sporadic at best, leaving individual units to fight isolated battles against overwhelming odds. By the end of June, German losses in Normandy had reached catastrophic proportions. The 352nd Division had been virtually destroyed, losing 1,200 men on D-Day alone and continuing to lose strength at unsustainable rates. Other German divisions suffered similar casualties as they were committed to battle against an enemy that seemed to possess inexhaustible reserves of men and material. Olmsen's battery continued to function until June 11th, when advancing American forces finally overran the position. During those 5 days, his guns had fired hundreds of shells at Allied targets, achieving numerous hits and causing significant casualties. But the strategic impact of their resistance was negligible. The Allied invasion had succeeded not because of superior tactics or strategy, but because of superior resources deployed with unprecedented efficiency. The broader implications of D-Day became clear to surviving German officers in the weeks that followed. This invasion represented a fundamental shift in the nature of warfare. Traditional military virtues of courage, skill, and tactical excellence had been overwhelmed by industrial capacity organized for total war. The Allied victory was not won on the beaches of Normandy, but in the factories of Detroit, the shipyards of Newport News, and the aircraft plants of Seattle. German prisoners captured during the Norman fighting described their shock at the sheer abundance of Allied equipment and supplies. American soldiers discarded equipment that German troops would have treasured. Food rations exceeded German officer allocations. Medical supplies were used lavishly for wounds that German medics would have been forced to ignore. The contrast revealed not just quantitative differences in supply, but qualitative differences in the societies that produced those supplies. Wehrmacht prisoners transported to Allied rear areas encountered supply systems that operated with an efficiency that challenged their understanding of military logistics. American field kitchens served hot meals to frontline troops within hours of combat. Medical evacuation helicopters transported wounded soldiers to field hospitals equipped with surgical facilities that exceeded many civilian hospitals in Germany. Ammunition supplies seemed unlimited, with American artillery firing preparatory barrages that consumed more shells in single engagements than entire German divisions possessed during extended campaigns. The psychological impact on German forces was as devastating as the material losses. Units that had believed in German technical superiority discovered that Allied equipment was not just more numerous, but often more advanced. The M.1 Garand rifle carried by American infantry was semi-automatic, giving individual soldiers firepower that exceeded entire German squads. Armed with bolt-action Mauser rifles, American artillery fired shells fitted with proximity fuses that detonated automatically at optimal heights, devastating German positions that would have been safe from conventional artillery. These proximity fuses represented a technological achievement that German scientists had declared theoretically impossible. Each shell contained a miniature radar system that calculated optimal detonation altitude automatically. The engineering required to mass-produce such sophisticated devices and make them reliable under combat conditions exceeded German capabilities by orders of magnitude. Yet American forces used these advanced munitions so routinely that individual soldiers were often unaware of their technological sophistication. Olmsen survived the war and lived until 1988. In post-war interviews conducted by military historians, he consistently emphasized that the German defeat in Normandy was not the result of tactical failures or strategic mistakes, but of fundamental miscalculations about Allied industrial capacity. The Nazi leadership had understood neither the scale of American production nor the efficiency with which that production could be converted into military power. The 7,000 Allied ships ships that Olmsen observed on D-Day morning represented the visible tip of an industrial iceberg that extended deep into American society. Every ship had been built by workers who had previously manufactured civilian goods. Every tank had been assembled by women who had learned welding and riveting in weeks rather than years. Every aircraft had been produced by a manufacturing system that prioritized quantity and quality simultaneously. Behind the invasion fleet lay a supply chain that stretched across continents and connected thousands of manufacturing facilities operating at maximum capacity. Steel mills in Pennsylvania produced armor plate that was shaped in Detroit factories and assembled by workers in California shipyards. Aluminum mined in Tennessee was formed into aircraft parts in Seattle and fitted with engines manufactured in Connecticut. The entire American economy had been reorganized for the single purpose of projecting military power across oceans. The German war economy, despite years of totalitarian mobilization, had never approached the efficiency of American democratic capitalism leashed for total war. German factories continued to produce luxury goods until 1943. German women were discouraged from entering the workforce to preserve traditional social roles. German industrial organization remained fragmented among competing bureaucracies that prioritized political considerations over production efficiency. The mathematical reality that confronted Olmsen on June 6th was the culmination of choices made by both sides years earlier. The Allies had chosen to maximize production and organize for sustained warfare. Germany had chosen to gamble on quick victories that would make sustained production unnecessary. When that gamble failed, Germany found itself facing an enemy that could replace losses faster than German forces could inflict them. Modern military historians recognize D-Day as the moment when industrial warfare reached its mature form. The side with superior production capacity, organized effectively and deployed efficiently, achieved decisive victory over forces that relied on traditional military virtues. The lesson was not lost on post-war military planners who recognized that future conflicts would be decided as much in factories and research laboratories as on battlefields. The Allied armada that filled Olmsen's horizon on June 6, 1944, was more than a military force. It was the physical manifestation of a society's capacity to organize its resources for war. Every ship represented not just naval power, but the industrial system that could build, maintain, and replace that power indefinitely. The German officer who watched that armada approach was witnessing the future of warfare, where victory belonged not to the bravest or most skilled, but to the side that could sustain the highest level of organized violence for the longest period of time. In the concrete bunker of the Kriesbeck battery, surrounded by the finest defensive weapons that German engineering could produce, Oberleutnant Zur C. Walter Olmsen learned the harsh mathematics of modern war. Courage, skill, and determination were not enough when facing an enemy that possessed unlimited resources and the organizational capacity to deploy those resources effectively. The invasion was not unstoppable because of Allied superiority in any single dimension, but because of Allied superiority in the dimension that mattered most, the ability to produce and deploy military power faster than the enemy could destroy it.